What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. Now, in this video, I want to show you how to solve logarithmic equations. All right, so they're going to be some long examples, but hopefully by the end of this, you'll get a better understanding of how to isolate your variables in a logarithmic expression, or I'm sorry, in a logarithmic equation, so that you can get an approximation for the value of x. All right, example 1. And example 1 is if I have the natural log of 1/2 x equals 1/4. I need to figure out what is my value of x. All right, so in order to do that, I need to get rid of that natural log. And in order to get rid of that natural log, I need to raise it by the power of e. So e to the natural log of 1/2 x is equal to e to the 1/4 power. All right, so e and natural log are inverses, so I'm just left with 1/2 x is equal to e to the 1/4 power. Now, in order to get x by itself, I need to divide by 1/2. Well, dividing by 1/2 is the same thing as multiplying by 2. Okay, so I can multiply this by 2 over 1 or just 2. All right, so what I'm going to do is I want to show you in a different color so you can see it. So I'm going to multiply by 2 there, multiply by 2 there, and then that's going to leave me with x is equal to 2e to the 1/4 power. Okay, now I can put 2e to the 1/4 power in the calculator, and it's going to give me an approximation of about 2.568, and that's your value of x. So there it is. All right, remember, we're just balancing these really like a basic algebraic equation, and everything goes back to the basics. Okay, whatever you do to one side of the equation, you have to do to the other side, and you still definitely have to use inverse operations. All right, example 2. Example 2 is 1/3 log base 2 of x plus 5 equals 7. Okay? Now, definitely want to get x by itself somehow. So first thing I want to get rid of is addition and subtraction. So subtract 5 there, subtract 5 there. All right, so 1/3 log base 2 of x is equal to 2. All right. Now, in order to get rid of this 1/3, because this is 1/3 times the log base 2 of x, it's the same thing as multiplying by 3 over 1 or multiplying by 3. So, like in the previous example, I want to show you in parentheses. So, boom, times 3 over 1 or times 3 over 1. Same thing. So these are gone. All right, so I have log base 2 of x is equal to 2 times 3 is 6. Okay, so now if I rewrite this in exponent form, 2 to the 6th power equals x. Okay, so I'm going to say, let's write it like this so we can stick with the rules. So we're going to say 2 to the log base 2 of x power is equal to 2 to the 6th power, because we want to write it to be consistent with the previous examples in the previous videos. So now here I'm just left with x equals 2 to the 6th power, and x, this one is not an approximation because you can actually get a value for 2 to the 6th power. So this is 64. All right, so x equals 64. All right. 2 more examples. 2 more. Let's go 2 more. All right. And this board has been getting some wear and tear these past couple of days. I've been putting in some work. I got a lot of videos coming for you all. Whole series on logarithms and exponents, to be honest. So if I have 15 plus 2 log base 2 of x equals 31. All right. Once again, I need to get x by itself. Well, let's move all this other stuff. So let's subtract 15. Subtract 15. That gives me 2 log base 2 of x is equal to 31 minus 15 is 16. This is multiplication, so I want to divide both sides by 2. So boom, boom, and I'm left with log base 2 of x is equal to 8. All right. Once again, I could write it, there's different ways. I could raise it 2 raised to this power to show inverse, but basically with my laws of, or the rules of logarithms, 2 to the 8th power equals x. Okay, but for the sake of the video, 2 raised to the log base 2 of x power is equal to 2 raised to the 8th power. This leaves me with just x, and as I told you, equals 2 to the 8th power. Once again, this one is not an approximation because I can find an exact value. 2 to the 8th power equals 256. Okay, so this one is not an approximation because I can actually get a value. All right, and let's do one last example. Let's do one last example. All right. And please use the benefits of video. Pause, rewind, stop, think, go step by step, whatever you need to do so that you can get an understanding. Because I try to do examples of the different types of problems that you're going to see. That's why videos like this one are so long, because I want you to see the different types of problems you'll get. All right, 3x equals 20. All right, so 6.5 times the log base 5 of 3x, or tree-x, equals 20. Let's get rid of the 6.5. So subtract 6.5 first. Subtract 6.5. Actually, no, that is incorrect. We don't want to subtract 6.5. We want to actually divide by 6.5 because that is multiplied right there. Okay, so we want to actually divide both sides by 6.5. My apologies for the mistake. Just to let you all know, I'm not perfect. So this divided by this, that leaves me with log base 5 of 3x is equal to 20 over 6.5. I want to leave it there like that for approximation purposes. Okay, and then now I want to do the same thing. I want to raise it 5 to log base 5 of 3x power is equal to 5 to the 20 over 6.5 power. Okay, now over here I'm just going to be left with the 3x, and that equals 5 to the 20 over 6.5 power. I need to divide by 3 because I want to get x by itself. So divide by tree, and x is equal to 5 to the 20 over 6.5 power divided by 3. This one is going to be an approximation. Okay, and I left it like that for calculator purposes. Remember, we're going to use the calculator for these values. Okay, that's going to give me 47.158. All right, so remember, you're going to be using the calculator for these, graphing calculator, scientific calculator, but it has these buttons. Please remember, the log button, just LOG, is log base 10. The natural log button just looks like LN, and the so those are the two main buttons that you'll be using on this. But remember, and also you can take a number to any exponent depending on what kind of calculator you have. I know on the TI calculators, I call it the house top. It looks like this. So like if I want to say 5 to the 20 over 6.5 power, it looks like that. And then I would say 20 divided by 6.5. All right, and that would be in parentheses. But it just depends on what kind of calculator you have. Be very, very mindful of notations, because with calculators, if you don't type in your values in the correct notation, it's not going to give you the correct answer. So be very, very mindful of parentheses, brackets, and other grouping symbols. Thank you so much for watching. I've got the solution to your math problems.